Okay, example 2 for rate of change. A car's distance in meters after t seconds is modeled by s of t is equal to the square root of t2 plus 3. What speed is the car driving at 3 seconds? Now, before we get into this question, a couple of things you may want to review. You may want to go over rationalizing expressions, more specifically rationalizing two-term expressions. And you may want to go over the third example for the slope of a tangent chapter, because we go over finding the slope of a tangent for a radical function, and we're going to have to do that in this question as well. So, back to this question, what speed is the car driving at 3 seconds? Well, they're asking for the speed or the velocity at a specific point in time. So right away we know that we're dealing with instantaneous velocity. So we'll have to find the slope of the tangent. So slope of tangent, let's rewrite the general formula here, is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. Now let's rewrite this formula in regards to this question. So our f in this case is s, so it's s, and our a value is going to be 3. We're looking for the speed at 3 seconds. So it's 3 plus h minus s of 3 all over h. Okay, so let's do s of 3 plus h and s of 3 on the side here. So s of 3 plus h, we just plug in 3 plus h for t into our equation. So it's 2 bracket 3 plus h plus 3. Okay, so we plugged in the 3 plus h for the t, and we represented t as a whole bracket here. So let's distribute the 2 inside the bracket. So we'll have the square root of 6 plus 2h plus 3. Then notice how the 6 and the 3 are like terms, so we could add them. So we end up with 9 plus 2h. Now let's figure out what S3 is. So S of 3, again, we just plug in 3 into our equation for t. So we'll have 2 times 3 plus 3. 2 times 3 is 6 plus 3. 6 plus 3 is 9. So the square root of 9 is 3. So now we take our values that we got for s of 3 plus h and for s of 3, and we plug them back into our difference quotient. So the limit as h goes to 0, s of 3 plus h is the square root of 9 plus 2h minus s of 3, which is just 3 all over h. Now, how do we get rid of the h in the denominator? Remember, that's our goal always, so we could plug in 0 for h. Well, whenever we're dealing with radical functions, we have to rationalize the numerator. So when we rationalize the numerator, it's a two-term. So we're going to multiply it by the numerator's conjugate, which is the square root of 9 plus 2h plus 3 all over the square root of 9 plus 2h plus 3. Okay, so this is like multiplying the equation by 1, which keeps it the same, but it's going to change the format. Okay, so let's continue this question down here. So when we take the numerator and multiply by its conjugate, that's a difference of squares. So the middle terms will cancel out if we were to FOIL it, so we could just multiply the ends. So the square root of 9 plus 2h times the square root of 9 plus 2h is just 9 plus 2h. And then negative 3 times positive 3 is just negative 9. All over h times, let's keep that that whole expression there in a bracket, so 9 plus 2h plus 3. Okay, so let's continue this question here. So notice how in the numerator the 9's will cancel out and we'll just be left with a 2h in the numerator. So let's rewrite this. So limit as h goes to 0 of 2h over h bracket the square root of 9 plus h plus 3. Okay, the h's cancel out, which we want, that's our goal. And now we could plug in 0 for h. So we'll end up with 2 over 9 plus 0 is just 9, so we'll end up with the square root of 9 plus 3. So the square root of 9 is 3, plus 3 is 6, so we'll end up with 2 over 6, which is equal to 1 over 3 meters per second. Okay, so the car is driving at a speed of 1 over 3 meters per second at 3 seconds. Okay, so let's do a quick recap of what happened here. So this here was side work, so I'll put a box to differentiate that. So we have the distance of a car is modeled by this equation, and we want to know what's the speed of the car at 3 seconds. So since we're given a position and time graph, and they're asking for speed or velocity, we know that they're asking for the rate of change. And since they're asking for the rate of change at a specific point in time, they're asking for the instantaneous speed or the instantaneous velocity. So since we're dealing with instantaneous speed or velocity, we got to find the slope of the tangent. We use the difference quotient. We're finding it at 3 seconds, so our a value is 3. So s of 3 plus h and s of 3 we did on the side here. Then we plug those values back in here. We did some algebra. The constants canceled out in the numerator, so we were left with an expression just in terms of h. So the h's were able to cancel out. And then we plugged in 0 for h. And we ended up getting 1 over 3 meters per second as our final answer.